way. Okay, so when we're trying to solve a system graphically, remember our trick, right? This is where we just solve for y into the graphing calculator, right? So no big deal. I want you to take me through, if you will, the steps here for the top one. Now remember, the top one is going to end up being y1, the bottom one's going to be y2. So what are the two steps in order I've got to do to get y1, the top y, by itself? Yes, ma'am.
Like a thingy says zoom out format. I don't really know what's going on.
What does it say?
I don't know.
Zoom out, format. No idea. Let's. I don't know. Okay, so what do we do? What are the two things I got to do? Yes, sir. Alex. No, you got it. You can do it. What are the two things I got to do to get that y by itself? First,
Well, I was going to say put that little fraction thing up.
Okay, we'll do it on the calculator. So we'll put the fraction template up. Remember, that's alpha, F1, and then I choose the first option, right?
Then you put 31 minus 8x because you minus 8x is on the other side.
Okay, let me get rid of that guy real quick so it doesn't confuse anybody. Okay, I go up to the numerator, and I start with what's already on the other side, right? We're trying to isolate the y on the left. What's already on the right? Well, the 31 is, okay? Go.
And you take away 8x
Okay,
on the other side, so
good.
it's negative 8x.
Perfect. Okay, there's the first step, isn't it? First step is we want to get rid of that guy, right? So we're going to subtract the 8x to the other side. Okay. Next step, divide by negative 8, because I got to get rid of that negative 8 that's in front of the y, so I go to the bottom. Put a negative 8 on the bottom. That gets rid of, come on. Oh, it gets rid of that, I guess. And I kind of messed that up. You get the idea, though, right? So we get y equals whatever we're left with on the other side. Okay? Okay, I think we're good. So there's the first one. What about the second one? Let's do this one with parentheses, just so we can accommodate anybody that's using a TI-83. So instead of the fraction template, we would do open a set of parentheses. 5. Start with a 5. That's already on the right. Plus 4x. We got to get rid of that negative 4x, so we're going to add 4x to the other side to get rid of it. Plus 4x, close the parentheses, now what's left? Divide by 10. And we got it. Okay, so then if I just, now what do I go to graph this thing? Zoom 6, because I don't know what the window is. So we'll reset the window by going zoom 6, and then it also graphs it. There's the first line. There's the second line. I can see the intersection this time, so I'm fine. I don't have to expand the window or do anything crazy like that. How do I get the intersection from the calculator? Second, calculate menu, 5. And then they're lines, so I just triple enter. There it is. Okay, and it wants us to round this to the nearest thousandth. So the answer we would have then for this one, the x-coordinate would be, it's pretty hard to see, but if I round that, remember when I'm rounding to the south, to the thousandth, how many decimal places is that? 3. 10th, 100th, thousandth, right? So that means I have to actually look at the fourth. So if this is 7.2916, if the fourth decimal value is a 6, what does that do to the third? Rounds it up. Good. So 7.292 is the x-coordinate. Y-coordinate is 3.4166. So what's that round to? 7. Okay, so there's my answer. Questions?
So you enter in, you look at 1.
All right, so let's look at another one real quick. Calculator, I'm gonna look at a different kind of result, okay? If we go back and do the same thing, let's just go back and edit what we've already got in there. So this top one, if I just clear out the top of the fraction and the bottom of the fraction. Oops. There we go. Okay, so on the top one, what do we start with on the right? What do we start with, though? I don't have anything in there yet. Negative 14, good. What am I going to do? Good. Add 32x to the right side and divide by 40. Okay, so there's the first one. Second one. Open a set of parentheses. Negative 7. Plus 8x. Add the 8x to the right side. Close parentheses. Divide by 10. Good. Okay. And if I graph that, now this time I could just hit graph, couldn't I? Because I know that I already had the window reset. But if I'm ever unsure, just hit zoom 6. So there's first line. And, ooh, okay. Looks like there's the second line. So are they the same line? It's kind of hard. I mean, it almost looked like it was separate. There's a way to tell, though. A student actually just showed this to me recently. This is really cool. The way you can tell. If they are the same line, if I do an intersection, if I go second, calc, intersect, and I just triple enter, okay, it won't do that. It'll actually give me whatever the x value was that I was on, it'll just go to that x value and give me the y value. Because it's telling me that that is an intersection. It's one of the infinite intersections. This means no, they're not intersecting, right? That's telling me no. If they were the same line, it would give me back an ordered pair, okay? So what are they? Well, maybe no solution. They might be parallel. We still don't know if they're going to intersect off the screen somewhere, right? So what could I do? I go back to my graph. Oops, I got to quit first, I guess. Okay, there's a couple things. It looks like they're pretty parallel. I could zoom in on this for one thing. I could zoom in and kind of, that might be helpful. Like, what if I just go zoom in to, do it again, zoom to, why is that not going in? Maybe it's not. I don't know why it's not. Oh, there we go. Maybe at the same time. Okay, so we can see there's two lines. We still can't really tell. Easy way to tell though, check the slopes. If I go second, calculate, remember which one's slope? Yeah, good. Change in y over change in x, number 6. So if I go second, calculate slope. Now look, this time it's got the cursor up on the top line, which is y1. So if I hit enter, it's telling me the slope of the top line is 0.8. Okay? How am I going to know if they're parallel? Okay, if the bottom line has the same slope. So I just go second, calc, 6. Now I got to get down to the bottom line, so I hit the down arrow to jump down to the bottom line. Hit enter, 0.8. They are parallel. Right? Make sense? So we can do all that stuff on the calculator. Okay? All right. Okay, I'm going to skip this one because we just did one. We just talked about one like that. We'll come back if we have time. Let's look at an inequality. Okay. So to do inequalities, this involves a little something here. What do we have to do on the calculator to graph inequalities? Good. Okay, we got to go to that app, don't we? So we go apps. Yours might pop up on that front screen, and mine's way down there, so I'm going to go alpha I to skip down to it. Enter. Says hit any key. Okay, so we're going apps, and then we're going down to the inequal app. Or inequalities, it's called one of the two. So then you can skip down there, if you just go alpha I, it'll skip all the way down. Any questions? Everybody able to get there okay? Okay, so once we're there, let's clear all these equations out that we had in our y editor. Okay, and we need to enter those inequalities. Now, I gave you pretty easy ones. You don't even have to solve for y in these. I mean, I kind of wish I'd given you some standard homework, but I did. So I'll make that easy on you. So if I'm going to enter these inequalities, how do I put in a greater than sign? Okay, I gotta put the cursor over the top of the equal sign, and that's when those soft buttons pop up down there, right? How do I access those? Yeah, it's the ones below, but I have to push a button first. Remember which one it is? Not second. Alpha. Yeah.
Well, how did you get those on this one?
You just put the cursor on top of the equal sign. Okay? And then if I hit alpha, it blinks an A, and that's going to allow me to push those F1 through F5 to choose those buttons. So it looks like I want F4 for this one, right? So there's my greater than. And then I just finish, right? Negative 2x plus 4. Okay. Less than, so I got to go over the equal sign, alpha F2. Scoot over. There is no fraction template, remember, on inequality. You have to just use parentheses. So in parentheses, I'll put a 1/2 x plus 4. Okay. Now what?
Drop it?
Drop it. So I'll go to zoom 6, reset the window. There's the first one. Notice it's a dashed line. There's the second one. Notice it's also dashed like it should be. Looks like a mess though. How do I clean that up? Yeah, good.
What do we do to clean it up?
Because you have that's a negative sign. Okay, so one more time. This looks pretty bad. It looks even worse if you have like 3 or 4 inequalities on there. This looks, can't even read it. So we got to clean that up. We want to just look at the intersection, just the overlapping region. So we go alpha, and then either F1 or F2 hits that wide button there. And first option. So alpha shades 1. It'll graph the first one, and then it'll erase as it graphs the second one and only keep the overlapping part. So there it is, right? Okay, and we'll just compare that to, now on Moodle, what you're going to be doing is just comparing that to your choices. And so that's going to be the one that's the right choice. Now, how do you know for sure that that's the right one? Because there could be some that look very similar. If I could just tell, for example, what the slope of that line was, right? And where that point of intersection was, and I can do all that stuff on the graph. If I want to find the point of intersection, remember that I can just hit this button right here. I can just say alpha point of intersection, and there it is. It tells me that it's at 0, 4. Well, I can see on my graph that that is the point of intersection, isn't it? Right? Okay. Questions? If I wanted to know, I can see from the graph here that I can make a slope triangle and see that that slope is -2. -2/1. If I really wanted to check that, I could even go second calc dy dx, and then let's see, which line am I on here? I'm on the right line, aren't I? If I trace along, I can see I'm on the correct line. If I hit enter, it tells me -2. Okay? Make sense?
So to find that, you said second calc, YDS, you online, hit enter.
Yep, hit enter to check the slope. And to find point of intersection, all I had to do was alpha POI. Okay, so let's move to the non-graphing calculator stuff.
That's all it's in the graph.
That's it? Those two kinds of problems.
How
How'd I get to 2? I just said I wanted to check and see if that line really had the right slope. And so I just said second calc dy dx, do 6. And then I just traced along until I could see that I was on the correct line, that little cursor was. And then I just hit enter, and it tells you. Okay? Okay, no questions on that? We're good? All right, put this guy away. Move on. So now we're looking at solving systems algebraically. Let's look at each of this is probably the biggest part of the test, of the algebraic test. So let's look at each of the different ways that types of problems we could see in different methods and how they'd apply. So this is non-graphic, yeah. Okay, so now what would I do with this guy here? Do I want to use, I got two methods, substitution and linear combination, right? Which one am I going to use here, obviously?
Substitution.
Substitution. Substitution is the one we use when it's easy to isolate a variable. Well, not only is it easy to isolate, it's already done for you. The y is already isolated in both cases, right? So I could just, for example, I could pick either one of these, it doesn't matter. I'll just arbitrarily pick the bottom one to be my substitution equation, and I'll just plug in for y in the top equation, right? So if I do that, everything that used to be a y in the top becomes a 7/4 x plus 3, right? And this whole equation then becomes 7/4 x plus 3, what used to be a y, equals negative 5/4 x minus 9. So let's talk about that. We got some options here too. We've got fractions, unfortunately. So I could just hang in there and do the arithmetic with the fractions, or as I've always recommended, what would I tell you is probably an easier thing to do here when you have fractions in an equation? Remember the trick? It was a great trick. Clear the fractions, right? We can get rid of them. All at once we can get rid of them. What's our trick for clearing fractions? Anybody want to take a stab at that, see if you can remember? What do I have to do? To undo dividing, which is the bottom of, I'm just trying to get rid of the denominators, right? To undo dividing, I have to multiply. So I have to multiply both sides through. I have to distribute through what number in this case? 4. The least common multiple of all the denominators. In other words, just the least common denominator of all the fractions, right? So in this case, I've only got 4s in the denominator, so that's my least common denominator. So if I multiply both sides through by 4/1, that's easy to do, and it's going to get rid of all the fractions. If I distribute the 4/1 to the first term, what's going to happen? Well, I'm going to get 4 times, when I multiply fractions, I just multiply straight across, right? So 4 times 7 is 28/4 is what? 28/4? 7, which we could see because we're going to see that those 4's cancel anyway, right? This is going to happen anyway. The 4's are going to cancel when I multiply by that first fraction. Okay, so that gives me then, for the first part, right here, I'm just going to get a 7x. Now I got to distribute my 4/1 to the other part. What's 4/1, which is just 4 times 3? 12. Okay, so the left side just becomes 7x plus 12. On the right side, if I do the same thing, what if I take my 4/1 and multiply by negative 5/4? Negative 5, yeah. If I multiply straight across, I get negative 20/4, but I could just cancel the 4's too. So negative 5x, 4 times negative 9, yeah, negative 36, and that's way easier, isn't it? Now I've got rid of the fractions. It's pretty easy to do. So what would I do from here? Okay, I'm going to, combine like terms, so add 5x to both sides. And this is just old hat. We've done a lot of this. So I end up over here with 12x. While I'm at it, what else could I do? Take away 12, I want to get the x by itself, right? So I'll subtract 12 from both sides. And I get, negative 48, good. So then if I divide both sides by 12, what do I get? Yeah, we get x equals negative 4, right? Halfway there, where would I go to solve for y? Where would I go to solve for y? Yeah, I go back to my substitution equation. I can pick either one here, can't I? This is the one that I chose, but really whichever one seems easier I could do. So let's whatever that squeaking is, can we find a way to get rid of that? So if I plug negative 4 into, like, say, the bottom equation, that's easy, right? I just get y equals 7/4 times negative 4/1. Let me get rid of some of this stuff here. See what we're doing. Plus 3. So what's 7/4 times negative 4/1? -7, isn't it? Right? The 4's cancel, so I get 7 times negative 1/1, or just multiply straight across if you want to and divide. Negative 28 over positive 4 is -7. Plus 3 equals what? Yeah, -4. So my answers are x equals -4, y equals -4, so written as an ordered pair, just looks like that. Make sense? Okay? How about this guy? Okay, this is a little different. This time, one of the equations is written in standard form, one's written in slope-intercept form. What would I do here? It's already done. Good. We've already got the y isolated, so we've already got our substitution equation, don't we? So we'll just substitute y into the top one. Does that make sense? Because we got the y by itself down here, or they did. It's already done for us. So if we do that, if I plug all this stuff in for y, don't I just get 4x plus 5 times that whole quantity, so I need it in parentheses? Right? Because I'm putting all that stuff in for y, and 5 is being multiplied by y, right? Okay, so I gotta multiply the 5/1, same as before. If I'm just distributing, aren't I? If I distribute the 5/1 to the first term, let's just say I multiply straight across. 5 times -4 is -20, over positive 5 is what? -20 divided by positive 5? -4, sure. So this first term just gives us -4 times my x. Right? And out front I've got my 4x still, right? Can't forget that. If I distribute the 5/1 to the 32/5, well, I could multiply straight across and get -160 over 5, or I could just cancel the 5's, couldn't I? Right? If I cancel the 5's, I just get -32/1, right? So it's just -32. Okay, so if we keep going, what happens? X's cancel. The x's cancel, and I'm left with the equation -32 equals 3. How do you interpret that? No solutions. Yeah, it's false, so there's no solutions, right? So this would be one in Moodle where we put in, I think it's NS, isn't it? Is that what you put in? Okay? All right. Questions? Yeah. Yeah, go ahead. Okay, so is this a substitution problem?
No.
No, it's not, is it? Not a substitution problem. Okay, this is one of those elimination problems or linear combination, whatever you want to call it. So I've got to figure out an easy way to get, or the easiest way to get one of the two variables to cancel, either the x's or the y's. Which terms would I probably get rid of most easily?
Why?
The y's, yeah. What's the smallest way I could do that? What could I multiply the top by and the bottom by to get the y's to cancel? 5 on the top, 3 on the bottom, right? Wouldn't that give me positive 30y on the top and negative 30y on the bottom? Okay? That's easier, that's better than, you might, if you don't see that, you might multiply the top by 10 and the bottom by 6, but you can use smaller numbers. 3 and 5 is better, because they're smaller. Okay, so if we do that, multiply the top one through by 5 and the bottom one by 3. When I distribute the 5 all the way through the top, what do I get?
Because a equal y is equal. And so in order to make the 6 and 30.
Equals
Oh, God. Equals 300.
negative 300?
Top? Oh, yeah.
Okay, on the bottom, 3 times negative 13? Oh, we don't need calculators for that. 39, so negative 39, right? Negative 39x minus 30y. That's there, we got it to work, right? The 30s will cancel. That was our goal. Equals
Negative 300.
negative, no, hang on, the bottom.
300.
Mm-mm.
No, oh, 3. Oh.
Yep.
180.
Good. Okay, so if I multiply, or excuse me, if I add, right, add vertically, the y's cancel, that's good. And I end up with 15x minus 39y. So that's gonna be, remember what we do with that, we subtract the smaller number from the bigger and keep the sign of the bigger, so it's negative. 39 minus 15 is
24.
24. It's negative, so negative 24x equals good, negative 480. So all I gotta do to solve for x is just divide both sides by negative 24. So those cancel, and that's gonna give me positive 20, good. Okay, so if x is 20, in this case, where would I go to find y?
The top one?
Top one, got smaller numbers in the top one, right? So we'd plug x equals 20 in right there. And we'd get 3 times 20 plus 6 times y equals negative 60. So that's just 60, right? 60 plus 6y equals negative 60. And what are the 2 steps in order to solve for y? Subtract 60. So I get negative 120, and then divide by 6. So y is negative 20?
Yeah.
So my solution set would then be, my ordered pair would be 20, negative 20 in that order, right? Okay? All right, we're almost there. Okay, so what about this? Now you gotta be able to solve these without your graphing calculator. I will have this good graph paper available for the test. I promise you, we'll have good graph paper. So let's do this on graph paper once so we can just see how this works manually. So the top one, remember all this corresponds to is just a boundary line and a shaded half plane, and that's it, right? So the top one, what's the equation of the boundary line? Okay, so what about the negative 2? Okay, y-intercept. Okay, so we got a y-intercept of negative 2, so we'll make this a red line. So there's my y-intercept. What's my slope? 1 over 1, so I would just go up 1 and over 1, or how about if we go like up 4 and over 4, so it's a little easier to connect these. I'm gonna play with my toys a little bit here, get out my ruler, and let's see, on this one. Don't you wish you had one of these? You don't wish you had one of these? You gotta be kidding me. It's so fun. Uh-oh. Boy, that's really... Okay, so that's not exact, but you get the idea. So here's my, now a solid or dashed line? Solid, okay. Oops, there. Okay, so there's,
Does it make it straight for you? Because you have the ruler there?
yeah,
That is pretty cool.
isn't that cool? So there's my boundary line. Now which half plane gets shaded here, looking at that inequality? If it's x is less than or equal to x minus 2?
Down.
Down, okay, good. So we'll shade, we'll just do it like this. We'll just, oh darn it, that's not what I want to do, whoops. Messed up my, here.
You're gonna have to clip that out of your video.
Yeah. My ineptitude, no, you guys already know, you already know what that's.
What's up, future Tyler?
Shut up.
Okay, next line, blue. Where's my y-intercept?
-4.
Negative 4. So right there. Okay, I've got a slope of, in this bottom one?
Down 1 over 1.
Down 1 over 1, good, so down 1 over 1. And there's another little thing I can do here that's kind of cool. I can just go like that, and then I can go grab that line, and I can have it turned into a shape. Oh, but it's red. I don't want it red. I want that blue. Okay. Oh, I messed up. Oh, I did mess up everything, didn't I? Oh. Okay, see, this is one of the pitfalls of technology right there. I don't really know what I'm doing. Oh, jeez.
Are you still glad that you have one of those?
Not anymore. I'm starting to think I'm starting to hate this thing.
I hate those things.
There we go. That's a little better. Okay. So is that one supposed to be solid or dashed? It is supposed to be dashed.
Oh, yeah.
So I hope this will let me erase. We'll see, I guess. This is really just an excuse for me to play with my toys like I say. Oh, okay, I can make it dashed.
Yeah, that's sweet.
Okay, so am I gonna shade above or below that if its Y is greater than that boundary line? Above. Okay. So, whoops. So where's the double shaded region then?
Right there.
Right there. So it's gonna be above the blue, below the red. So if I had to shade that in, I guess that would be kind of like down in there. Right? Does that make sense? Okay, good. Questions?
What would we be putting down?
Okay, so then you're gonna choose the graph that corresponds to that.
Okay.
So you're gonna graph it, and then you can see where the intersection is, and you can, right, so you can make the choice based on your graph.
The whole triangle thing is kind of confusing.
Say it again?
Like, I know why we shade them up and stuff, the whole and I know why the triangle is a triangle because they all intersect in the same spot. But what does that have to do with anything? Like, are we gonna have to write where the triangle is, or?
Okay, so on the test you mean? No, so on Moodle, so here, good question. So what are you, how is this gonna translate into a test question for you guys? I'm gonna give you a series of like 6 or 8 choices, and you'll have to say, okay, they're all gonna be kind of tricky choices, but you're gonna have to pick, based on your graph, which one does that match up with? Okay? All right. Last one, maybe. Yeah, last one. Okay, this is a really easy one, but people had some questions about this. It's a little strange, but it's very simple, actually. So what about this? If we have the, it says choose the graph that correctly represents the solution of the system. Well, what does the first line look like? If I have the line y equals 3, what is that? Okay, is that going to be horizontal or vertical? Horizontal, y-intercept of positive 3, so it just dashed or solid? Dashed. So I'm going to try to, I'll just kind of freehand this, but looks like that, right?
Nice.
Okay, and I'm going to shade everything above that, correct? Y is greater than that?
Yeah.
Everybody agree? Okay, bottom line. I said bottom line. So we go down to -5, it's horizontal. Good, so, oh, man, let's not do that. Let's go back. I meant to do, gosh, guys, sorry, too late. Okay, so -5, -1, 2, 3, 4, 5, so right there. There's my bottom line. I'm shading everything greater than that, so everything above, right? Yeah. Okay, so then isn't that just all this stuff? So where's the double shaded region gonna be? No, not in between. It's gonna be above, yeah. Right, the double shaded region this time is just everything above the top line. So it just looks like, it's just purple probably, huh? Right? Does that make sense? Now what happens if I'm just kind of curious, if I overlap colors here, do they really overlap or do I just, oh yeah. Oh, so look what I could have done something even fancier there.
Yeah, you should've.
I could've made purple, couldn't I?
Yeah.
Maybe you should have made purple.
Now you know it for next time.
Yeah. All right, yep. Note to self.
That's the highlight.
All right.
You got that up.
Yeah.
But don't raise those,